This video will cover quiz number 3, sections 3.1 to 3.4, and this would be specifically on question number 2 and question number 3. So question number 2 says complete the table by finding the balance A when P dollars is invested at a rate R for T years and compounded N times per year. Round your answer to the nearest cent. And they tell us that P is 4,500, R is 7%, and T is 20. And they give us N is 1, 2, 4, 12, 365, and continuous. So the first thing you want to do is write down the formula for compound interest, which is A equals P parentheses 1 plus R divided by N raised to the power of N times T. And what we're going to do is we're going to be filling in the values for each variable that is given. So for example here, we don't know what A is. P, they tell us, is 4,500. R is 7%, so we want to write that as a decimal. And N, we'll use 1 for the first row times 20 for the time. So we want to simplify this. 0.07 divided by 1 is 0.07, plus 1 would be 1.07. 1 times 20 is raised to the 20th power. So you want to use your calculator. Okay, so first we're going to have 1.07 0.07, and we want to raise that to the power of 20. You don't want to round until the very end. So we get 3.86 and so on. So then we're just going to multiply times the 4,500. So we get 17,413. And then we want to round, so 58.58. So let's try the next one. So we have A equals 4,500 of 1 plus 0.07 divided by 2, 2 times 20. 2 times 20 is 40. And we can do 0.07 divided by 2 is 0.035 plus 1 will give us 1.035 plus 1. I'm going to raise that to the power of 40. So we get this long number. Again, you don't want to round it, because if you do, then your final answer is going to be off by a few cents. And so for this one, we get 17,816 with 67 cents. And so you want to keep doing this. We're going to replace our N now with 4. Okay, so we have 4 times 20. 4 times 20 is 80. So 0.07 divided by 4 is 0.175 plus 1 would give us this. So we can plug this into our calculator. So we have 1.0175 raised to the power of 80 times 4,500. So we get 18,028. So 18,028 with 76 cents. Again, make sure that you are rounding up to the 2 decimal places for cents. So we continue the process. So now we have 4,500 of 1.07. Okay, let me erase that. Of 1 plus 0.07 divided by 12. And 12 times 20. So 0.07 divided by 12. So 0.07 divided by 12. Or again, don't round until the very end, plus 1. Gives us 1.058 and so on. So we would actually leave all of this 1.0058 333 and 12 times 20, 240. So here I'm just going to raise this to 240 times 4,500. So we get 18,174. And the decimals be 32 cents. And if we do the same for the 365, then you should end up with 18,245 with 95 cents. For continuous, you want to use a different formula, which is A is equal to P ERT. So here we still know that P is 4,500. The rate is still 0.07 and the T is 20. So we use the calculator. I'm going to do second E. I'm going to put in here 0.07 times 20 and then times 4,500. So we get 18,248 with 40 cents. So 18,248 with 40 cents. Okay, so that is how we would use these compound interest formulas. And then for question number 3, is the number V of computers infected by a computer virus increases according to the model Vt equals 100e raised to the power of 4.623 times t. So I'm going to go ahead and write this formula since we're going to more than likely use it. So I'm going to have V is equal to V of t is equal to 100e 4.6 23T. And they want us to find the number of computers infected after 0.5 hours, 1 hour, and 2.5 hours, and round your answers to the nearest whole number. So the number of computers infected is given by V, and so the time for the first one is 1 hour. So we get 100E 4.623 times 1. So we put this in our calculator. We're going to have second E of 4.623 times 1 times 100. Okay, so we would write down, so my answer here would be 10,179 with 90 cents. So then we would do the next one. So instead of for T, we're going to substitute 2 hours. So we put that in our calculator. So we have second E of 4.623 times 2 times 100. So V of 2 is equal to 1,000,000 1,036,303 with 0.6. And it does say round your answers to the nearest whole number. So for this one, the nearest whole number would be 10180. So 10,180. And this one would be 1,036,303. And then the last one is 100 times T. So we would substitute 3. So we plug it in. So we have 4.623 times 3 4.623 times 3 times 100. So we end up with 105,494,585 infected computers.